Hello, it's Mr. Prickett. Just going to try to explain a little bit more about this assignment, the probability game of chance. And one thing I want to talk about is, some of you may have seen the previous video, or the video was up there. The course has been changed slightly in terms of its order, so that's partly why the expected value, which is actually now near the end of the course, is included in this assignment. This used to be the summative assignment at the end of the course, and of course we've changed it around to more align with what you would expect in the classroom. Now, with that, I'm going to help you a little bit with the expected payout and the expected value to understand what that means. The main thing, though, is there is a spreadsheet provided for you, and that essentially is your template for the number crunching part of it. And the game is really all about coming up with three outcomes for some sort of scenario or a combination of scenarios likely that will provide some sort of a payout or some sort of a prize for a certain amount of money that you pay to play the game. So like a typical lottery, you pay $5 for the ticket and you've got a certain chance of winning a new TV, or maybe it's a free coffee, or maybe it's a car. So obviously the probability of winning the car is lower, but of course the value of the prize is higher. So that's up to you. So I'm just going to go through some basic, simple possible outcomes with you to show you how that actually is inputted into the actual spreadsheet. So the first one, I've typed these in already. So I said, okay, we're going to take a die, we're going to have a coin, and we're going to take a deck of cards. And our outcomes here are shown in the spreadsheet here, 1, 2, and 3. And I'll go through the first one with you. Roll a 1 or a 2, flip ahead, and draw a heart from a deck of cards. So what's the probability of actually that happening? Well, because these are all independent, we multiply them all together, and we know that the rolling the 1 over 2 is just simply 2 out of 6 possibilities for rolling a die, 1 or 2. So when you go to the probability as an expression, to write it as an expression, we just put the quotations before anything that we show. It's almost like showing our work in a math problem. But we're just simply going to write that as 2 divided by 6, or 2/6 probability of rolling a 1 over 2. And of course, multiplied by flipping ahead, well, that's a 50-50 chance, so 1/2, 1 over 2, times, and of course I just use the asterisk to represent the multiplication. And drawing a heart from a deck of cards, well, there's 13 hearts in a 52 card deck. So there's our expression. Now, the probability as a decimal is actually the calculated probability of having all those things happening. So that means the probability of such would be 2 divided by 6 times 1/2 times 13 over 52, which is really just the same as 1/4. So the probability I just calculated, you could use your spreadsheet too, but to be honest, I don't think that's going to save you much time. And put it in. Bang. So 0.04. And you can think of that as a 4% approximately chance of having that actually happen. Now here's the trick. You've got to decide on what your payout is. Now I've decided to keep it simple, at least for this video. I'm going to charge people $1 to play the game. And my expected value range of the game is 40 to 60 cents. And what that means is I put $1 down and I expect to win back somewhere between 40 and 60 cents. That's what our target is, right? Because you can't make it so low that no one wants to play your game, but you also don't want to make it so high that you never make any money. So we're just suggesting 40 to 60 cents that your customer will get back. So you're going to pocket basically anywhere between 60 and 40 cents. So the payout, well, that'll be up to you, but I'm just going to start with this. Let's just say $5. So I'll put in the payout for my first outcome as $5. Great. Okay. Now here's the trick. We don't know really what expected value, expected payout would be per outcome. So what you simply have to do is multiply the payout by the probability. So payout times its probability. So how do you do this in a spreadsheet? The nice thing about spreadsheets is you can do these calculations very easily. Equals C3. So you click on that C3. See, it shows C3 now. Use the asterisk to indicate multiplication times D3. C3 times D3, or 0.041666 times $5. 21 cents. So your expected payout for that outcome is 21 cents. Now, you repeat this again for the next two. So I'll do the next one. Roll of 3 or greater. So that's, again, write the expression with the quotation just so it doesn't think it's a formula. 4 divided by 6 times, again, 1/2 for the flipping of a coin, and times drawing a black card. Well, that's half the deck, isn't it? So that's 26 over 52 if you want to do it that way, or just a half. Again, recalculating that probability by multiplying all those together, 0.1666667. Okay, there it is. Notice that if you look at your probabilities, the probability of getting this is a lot higher than getting this, about 4 times as much. And if you think about it, it makes sense because there's a higher likelihood of getting a black card there versus a heart, just in looking at that. And plus you've got a lot more chances, or a lot more opportunities to roll a winning roll in this outcome than the previous one. So when you think about that, sort of like the car and Tim Hortons, roll up the rim, the odds of winning the car is extremely low. Although I didn't win a barbecue once, which I was quite excited about. But the odds of even winning a barbecue are very, very low compared to winning like a free donut or something like that. Although it seems these days I can barely get a free coffee. That's just the way it is. So think of that in terms of the higher the probability, the likelihood of a better payout is low. So you want to award people or reward people for getting something that's easy with less money. So let's say you get your money back if you do get that combination. So again, the nice thing about a spreadsheet is, so I'll say $1 for here, and let's go here. Expected value, payout per outcome. So we just multiply the payout times the probability. Do the same thing again. Now you can do it manually, or a cool thing about spreadsheets is if you go to the bottom corner and you see that little plus sign up here, you can simply drag down the 3 cells and it automatically will do the calculation for you. It will think about it as this times this, this times this, and then the third one would be this times this, which we haven't done yet, of course. That's why it says 0. So now, we've got 2 of the outcomes in, and it says, what's the expected payout for all outcomes? So what you simply do is add all those together. So what you can do is say, okay, sum, equals sum, bracket, and then drag those 3 together. Close bracket, enter. 38 cents. Cost to play the game is $1. At least that's my game. And the expected win or lose, well, you're out $1 already, right? So what you want to do is simply say your expected value. Let's just think of it as, okay, how much do you get back out of your dollar? So that would be equal to this minus E7, cost to play, minus the expected payout. Okay? So 62 cents. So that's how much you actually lost so far per game. So if you think about that value, what we got to do is get it in the range of 40 to 60 cents. So we do have another possible outcome we still need to add. So I said, okay, roll a 6, flip ahead. So that's 1/6 chance times 1/2, times draw a red face card. A red face card. Oh, okay, well this is low. There are only 6 red face cards out of 52. Jack, Queen, King, Jack, Queen, King for each heart and a diamond suit. So again, calculate those out. This is really low, 0.0096154. So now what you want to do is, okay, well, let's just do this. How much should I actually put in for the payout? Well, it's up to you, but maybe you put in $3. Well, that's not very much. Maybe $6. Okay? Or whatever you like, as long as it fits in terms of our game. So right now, this means that on average, cost $1 to play. Expected payout for all the outcomes is going to be 44 cents. The difference is going to be 56 cents. Perfect. If you have any questions about this, please give me an email and I can further clarify. But if you can also, if you want to figure out a little bit more about that expected value, you can take a look on Unit 7. I'll open up the first couple of units in Chapter 7, although it gets into some details about probability and distributions that we don't want to get into really at this stage. But you can certainly take a look at that as well. Okay, thanks.